Howdy, it's tubalcain, and this is tips number 235 on the Atlas lathe, and the subject of this particular video is the tailstock on the Craftsman lathe. Now up to this point I've done 14 or 15 videos on this Atlas lathe covering the various parts in detail, and this one is on the tailstock, and the next one will be on the headstock, which will conclude this series, so be sure and watch them all. This lathe has a 12-inch swing, meaning there's approximately 6 inches between the center on the headstock, if I had a center mounted, and the saddle here of the carriage. And that's how we size lathes. And also this lathe probably came in different lengths, so it's about 36 inches between the centers. There's a yardstick to illustrate that. So the longest workpiece that could be held is about 35 or 36 inches. The tailstock can be slid back and forth on the lathe bed and is aligned here between the rails or the ways of the bed, as is the headstock, and that's what gives the alignment on this type of lathe. But on a V-way type, the alignment would be obtained by the V's. So this is probably not quite as accurate, but yet it seems to do the job. This is the quill of the tailstock. Some people might call it a spindle, but it's correctly called a quill. And in this case, it's a number 2 morse taper. And the dead center is simply held in there by friction, by tapping that in. Too much torque, of course, is probably going to cause this to twist. But any tool with a number 2 morse taper can be held in the quill. And here's a drill chuck, various live centers, ball bearing centers, a reamer, and a drill. And they can all be held in there simply by putting them in place. Make sure that you wipe them clean and wipe the hole out as well. And then put the tool in and tap it with a lead hammer. In order to remove the tool, just back up the quill as far as you can, and it should eject automatically. Now, if it doesn't eject, and this isn't long enough here to get pushed out, I'll show you another method for that later, and that's to remove the quill altogether and use a ramrod from the back or threaded side. The tailstock can be positioned any place along the bed and then locked in place with the clamp screw, like such. Now, the tailstock consists of 2 parts. It's made of a bottom and a top, and I'm going to take it off in just a second and show you how that looks. But up here again, the quill, and it's graduated here in 1/16 of an inch so that you can tell how deep you're feeding or drilling. And this is the quill lock here, so if you tighten that up, of course it prevents this from turning. Make sure that's loose and do not force this. And of course this is the hand wheel. And right here on the older lathes you're going to find the oil dauber. You won't see that on the newer lathes, but the purpose of that was it was a place to hold white lead as a lubricant for the dead centers. But when I was a student in high school, we had all those filled with extreme pressure lube, and then the oil was always handy because we didn't have ball bearing centers yet. We just had these dead centers, and we would just dab just a little bit of that oil on there before we put the work on the center. So that's the oil dauber. Later on, of course, ball bearing centers became available, and so this is kind of a archaic thing yet, but interesting enough. I took the tailstock off so you can see the bottom of it, and this is what rides on the ways. So make sure that you keep this lubricated. I've seen so many tailstocks that are badly worn, especially on the end toward the headstock, and then you can no longer get true alignment, and I'm going to show you that with a dial indicator, what happens when that gets worn, as well as the bed itself getting worn. So keep it lubricated with a whey oil, or at the very least some 20 weight. From this view, you can easily see that the tailstock is two pieces, top and the bottom. And right here we have index lines, and at the moment they are well aligned, but you can see witness marks. And the top can be slid back and forth from the bottom. And the purpose of that is to give you a tailstock offset that you might use when you do tapers on long pieces. That's the second method of cutting a taper on a lathe. But once you've got that set, you really don't want to change it. And I'm going to talk about indicating that in here in just a few minutes. But the way that works, of course, there's a set screw here on one side that's slotted for a screwdriver. Sometimes it'll be an Allen head. And then one also on the other side, and you can see that they push against each other. So with the tailstock unclamped, that is loosened and mounted, you can move it back and forth until you line up those witness marks that I just showed you. So that's how it's constructed. This is the clamp, and it clamps up from underneath the bed and can be tightened with this. And that's how you lock it in the longitudinal direction. It's absolutely essential that you do not allow any chips or swarf between the bed and the tailstock. So make sure everything is clean, but I like to lubricate it in this manner by lifting it just a little bit. I'll squirt some oil on there, and this is the 20 weight, but of course you could use the whey oil as well. And I like to lift it a little bit. Bring it over the oil back and forth, and then you're sure you've got good clean oil underneath it. From time to time, your drill bit or your cutting tool is going to spin on you. It's going to slip in the Morse taper and it's going to spin. When that happens, there usually is damage to the shank here, but also it can get galled or torn up a little bit inside here, and that needs to be cleaned up, or your drill cannot get seated properly there. It's going to spin even more. So using a number 2 Morse taper reamer, see that is tapered, make sure it's clean, and you can put it in there and just ever so gently, not under power, but just with your hand, you can clean that up a little bit. And if you're cutting anything at all, you will feel it. Don't force it and do not wobble it. And you may want to support it on this end with a center that's held in the headstock, and then remove it. And sometimes you're going to even see a few little chips on there. And then wipe it clean using a clean towel and a screwdriver or something in there, so you can turn the rag and get any chips out of there. And be sure and have a few drops of oil on there whenever you are installing a tool. Now let's take the quill all the way out. So just crank it and it will come out. Boy, that's a tight one. That was a tight one. This doesn't back out real well on this Atlas lathe, and that's the reason for that. But you can see there's a thread in there. It's a left-hand thread. If your center gets stuck and it won't come out, use a little rod. Here, in this case, it's just a bolt as a ramrod, and you can tap it out. That might happen to you from time to time if the center or the tool isn't long enough back here. You might have trouble getting it out. You can remove the quill by backing the handwheel all the way and then just sliding it out. And notice there's a keyway on the bottom side. There's going to be times when your center doesn't come out. You're not able to back this up far enough to press it out, depending on the length of the center of the tool. Now, if that happens to you, take a rod, or in this case that's just a 5/16 bolt, and you can use it as a ramrod on this side. Now catch the center, don't let that fall on the floor, but just tapping it with a hammer, you'll be able to knock it out. And there's the threaded end, and remember that's a left-hand thread. And here's the key that goes in the keyway. It's threaded from the bottom. It's nothing more than a long set screw that has been flattened on two sides with a lock nut here so that you'll get it to the right depth. It can also spin on you and you lose your orientation, so you might have to loosen that up and rotate it a little bit so that it fits into the keyway of the quill. Also, looking down the bore of the quill, you can see the quill lock. And that's a two-piece Zamac affair, and I'll pull that out in a second to show you how that tightens up against the quill in order to lock it. Let me pull that lock out. You see it pulls out, made of Zamac, and the bolt is square head on the bottom, and as you tighten this, it just pulls the two of them together and clamps against this. And that seems to hang up a little bit on these Atlas lathes, even though it's well oiled. Notice there's a spare set of them on the back side, so you can put it in either way. And then the clamping screw. In order to get the quill back in, sometimes I have to separate this and install one from the bottom and one from the top. So you might have to go through that depending on your lathe. Let me pull the screw out and show you what that looks like. Now there's a double jam nuts here on the end, and some of the lathes might have a lock nut there, but there's two of those, 11/16. Atlas sure liked that size, 11/16, and this is also die cast, probably Zamac, but chrome plated and rather pretty at that. And you can see the keyway in it. And a corresponding Woodruff key right here, if I can get it out. Sometimes it helps to tilt it just like that and then tap it and it'll come out. Be careful you don't nick anything or damage anything, and don't lose the Woodruff key. Then the entire screw can be pulled out from the other end, and you might need to push it like that. There's an oil hole right here. This is threaded in, I believe, rather than pressed. They call this the bearing for some reason, and it's not going to come out easily, and there are no flats on it, so I'm not going to remove that. There's the screw, and don't lose this washer. Sometimes that falls loose inside of the tailstock, so make sure that's on there. You can see the keyway. This is a 1/2 diameter, 10 threads per inch, left hand Acme. So you don't want to have to make one of those, and this looks like it's in very good shape. And you say, why always the left hand? Well, if you didn't have a left hand like that, it would push the quill here in the wrong direction. In other words, you'd have to turn the hand wheel in what is not the normal position. And it would be like having your steering backwards on your car, you know, that you had and we made a go-kart like that one time when we were kids. You had to turn it the wrong way, and we constantly crashed it, but that's why there's a left-hand thread on here. Furthermore, since this is 10 threads per inch, it does not coincide with the graduations here, which are 16ths. So in other words, a full turn of the hand wheel here isn't going to move you one graduation. Be sure and lubricate that when you put it back in, and clean it if it hasn't already been cleaned. This one's in good shape. Use a little solvent on it. I've cleaned and lubricated the screw, reassembled it using the Woodruff key. Now I put one of the jam nuts, remember there's two of them on there, and at this point you have to make an adjustment. If you tighten this too tight right now, it will pull that up against, and you can't turn this. In other words, you almost have locked it. So you need to back that off just a little bit with your, again, 11/16 Mac wrench. Back it off so it turns freely, but yet there is no play here, end play to speak of. Put the other lock nut on, and then using a blue point tappet wrench like this, holding the one thin nut and turning this with the other and locking them so that it turns freely. with no end play, virtually. It's raining hard here in Illinois, June of 2015. You may hear it on the roof. Now when you get ready to put the quill back in to the tailstock, make sure it's clean. And clean that with a rag and your finger. Make sure that the key is oriented correctly, and let's have a little oil on this. Always cleanliness and oil. This is easy enough to oil by extending it also. And then in it goes. And you'll feel it when the key aligns. I haven't put the lock in yet, so I'll do that now. This is the lower part of the quill lock. Square hole, square headed bolt. And I'm going to insert it from the inside, or from below. And with my finger holding it up from the bottom, I take the other half, which has been oiled, put it in like that, put that thick washer on there, and the quill lock itself, quill lock handle, that is. And that can be tightened up as needed. And then even a little more oil on here. Work that around. It is not the purpose of this video to show you how to align the tailstock. Again, getting these graduations to coincide here. And that is done by loosening this and, again, working one of these screws against the other, and it can be moved back and forth. And I have several videos on that, so be sure and watch those using a test bar, and there's so many different ways of doing it. But I'm just going to show you with a dial indicator now, the coaxial indicator, on how to check to see if it is correct. And I'm not going to do it here. I'm just going to show you how to do it with an indicator, or how to check it with an indicator. This can be done with many different kinds of indicators, but I'm using the coaxial indicator, and it's so good to use during a demonstration because the dial will always face up toward the camera or your eye, and you don't have to use an inspection mirror or anything of that nature. And my coaxial indicator is mounted in the 3-jaw chuck and the rod here to prevent it from rotating. And this isn't really a job where we are going to do it under power, but it can be done under power. Now I want to indicate the quill. If I put the feeler up against the quill and rotate this, what's going to happen, I got to loosen the belt. What's going to happen is that this feeler here is going to run into the keyway on the bottom here and probably break this or damage it, or in some way cause a problem. So I'm going to indicate using around the dead center, which I know to be an accurate, good one. There's no corrosion, no nothing on there. And clean this off and clean the quill, which I've already done. Mount that in there and bring it up. And I'm going to I'm going to also lock this, because sometimes there'll be just a little separation here on certain brands of lathes, not so much the Atlas, but I've noticed that on other lathes. So make sure you've got that tight. However, it has to be loose if you're making an adjustment here, but I've got it tightened. And I am not on the ground portion here. I'm right here. I know that's tapered, but that's not going to be relevant. I love it when the dentist turns off the parabolic light, because you know he's done giving you pain. Well, I turn it off to reduce the reflection here on the indicator. Hopefully that shows up. But the feeler, again, is against the center. And to start with, I'm just checking it in the cross direction here, and I'll rotate the spindle exactly 180 degrees. And you're going to see that it's pretty much dead on. Not pretty much, it is right on. Not get it any closer than that. If it's off, you can adjust it with the tailstock offset as shown earlier, or talked about earlier rather. Now let's check it from top to bottom, but there really is nothing you can do about that. So right here in the very top position. You can see it's on, and I'll rotate it now just till the feeler is on the bottom. That also is real good. Perfect, really. But you're going to find that this last test that I'm making, top to bottom, will often be way off on your lathe, and that's probably because, not probably, it's because the bottom of the tailstock is worn, or the bed is worn, or both, and there really isn't anything that you can do about that, and it's maddening when you try to make adjustments and compensate for that, and there really isn't anything you can do about it, and that's something that isn't talked about much. But the only possibility for that is this. And another thing that happens is that the wear on the bottom of the tailstock is much more on the front here, so the whole thing is tilted like this. So the quill, instead of being parallel to the bed, is tilted a little bit down. I'm exaggerating greatly. Now the only thing that can be done is to send it to a machine tool rebuilder where they would grind the bottom of the tailstock, but they would also have to grind the bottom of the headstock and match them, and that would cost far more than what the lathe is worth, so that's not something you're going to do. But some people put shims between the top and the bottom half here. But they'd be very thin shims, and if it's tapered, you're probably not going to be able to correct it. But that is sometimes done, not something that I want to fiddle with myself. A coaxial indicator can be used with the machine on, but the maximum RPM is 700, and I'm nowhere near that. I'm at about 160, but I'm just trying to illustrate again here. And you see the little fluctuation there, but overall, quite good. See how this is set up. And you might want to get yourself one of these coaxials if you don't have one. They sure are handy. Mainly they're used on a milling machine, but I like to use it for this application as well. But not something I do very often. And be sure and check the many other videos that show how to align the tailstock by other methods, because I'm going to say that probably 95% of people don't have one of these, and I have only owned this very recently myself. This is a homemade clamping wrench. The original was missing when I bought this lathe, so that's nothing more than a box end wrench cut off. And you do not want to use too long of a wrench where you get too much leverage, so that's just right, about the length of the original ones. I didn't think I could talk this long about something as simple as the tailstock on the lathe, but I guess I have. And hope you enjoyed this video and continue to watch my videos, and there'll be just one or two more on the Atlas lathe, and go back and watch all of them starting at number 220, Machine Shop Tips. This is tubalcain saying so long for now.